Yeah, it's on. Hello. Hey, me again. Now you get tired of me by now. But anyway, welcome to the inaugural Design on Cloud Pavilion. And I think that we are all here because we all know how important this design infrastructure is to the EDA tools, to the whole design ecosystem. Without it, I don't think this whole electronic product is going to even be possible, right? And so I think because we all recognize the importance of it, and we actually put together the first Design on Cloud Pavilion, also the Design Infrastructure Alley. And we have lots of makers and shakers of the people working in this area here. As you can see, lots of motion there. And so here, I think you will hear a lot about, people will exchange their ideas, what they learn, what they want to learn, or what they want to share. And I think it will be a great 3 days ahead of us. And with that, I think I first want to congratulate the people who have put this together, who have made this even possible. And one of the key people I really want you to know is Derek McGill, who I actually want to introduce, give a quick introduction, and then we'll let him take over. Now, Derek has been an engineer IT support for 20 years, and we just chatted. He said he was at Unix desk, help desk. That's how he started. And I said, I started that way too. And when I was in grad school, I was a helper at Unix help desk. So, but over the years, of course, he has done a lot more great things. He has held various architecture and leadership positions. He currently is the engineer cloud architecture lead and the global EDA license infrastructure lead at Qualcomm. And Derek has also served as the chairman of CLUG since 2015, and is the executive director of the Association of High Performance Computing Professionals. And I think I'd recognize from the shirt there. So without ado, let me welcome Derek, and he will take it from here. Thank you.
Well, good morning, everybody. All right, can you hear me all right out there? All right, perfect, thanks. Good morning, everyone, and welcome to the inaugural Design Infrastructure Alley at DAC in 2018. I can't tell you how excited I am that all of you are here today. I'm really excited to see some familiar faces in the crowd, but I'm super excited to see all of the unfamiliar faces in the crowd as well. It's great to see some new folks out there. It's going to be a great week. Welcome. So before I get into my talk, I wanted to spend a couple of minutes and give some thanks to the folks who really made this thing possible. Without these people, we would not be here today. And first and foremost, I wanted to thank all of the exhibitors who are right there behind us. They're pretty busy right now, it looks like, which is great. We've got some really big companies that have signed up to be here this week. We've got some really small startup companies that have signed up to be here this week. And it's great to see that kind of diversity out there, and it gives us lots of fodder for being able to make advances in our infrastructure environment. So thanks so much for all of the exhibitors who have taken time out of their days and taken money out of their budgets to be here. So be sure and visit them. We've got some great suppliers here. I want to especially thank two suppliers who are the sponsors of our Design on Cloud Pavilion, which is this stage area right here, Microsoft and Google Cloud. Thanks to their generous support, we were able to have this happen this week, and I can't thank them enough. So please be sure, and the Google folks are here, and I know the Microsoft folks are wandering around somewhere. So if you see them, be sure and thank them. And then finally, I have some very special thanks to some individuals. I want to thank, first of all, the DAC Organizing Committee. You just saw Sharon, who's this year's DAC chair. I want to thank her. The ACM, the IEEE, and the Electronic Systems Design Alliance. Those organizations are the ones who collectively put on DAC, and it was them who listened to this crazy idea to talk about engineering infrastructure at DAC, and they said, that sounds like a fine idea, let's go ahead and do that. So thank you very much for your support. We wouldn't be here without you either. I want to thank Patrick Filippelli of Hall Erickson. He did a tremendous job in following up with all of our suppliers and really letting them know what the value of this week was going to be for them. Michelle Clancy of Canyon Communications, she's been intimately involved in Design Infrastructure Alley. She's done so much more than that. She's done a tremendous job for us. And I also want to thank Paul Cohen of the ESD Alliance. He was, hands deep in everything that we were doing. And then finally, back there, we've got Bob Smith.
Check 1, 2. Check 1, 2.
All right, and finally, we've got Bob Smith back there, who's the executive director of the ESD Alliance, and without his support, he was the one who actually took the presentation up to the DAC board. So thank you so much, Bob. You were a key component of making this thing happen. So can we give all of those folks a quick round of applause? Thank you so much. Okay, so let's talk a little bit about why we're here. So the elevator pitch that I used to sell this idea to the DAC organizing committee was every year we get together at DAC and we talk about ways to make new tools and new methods to create chips. But we never talk about the infrastructure that's needed to create those chips and those systems. And it's critically important, and it's becoming very difficult to scale all of those tools and systems out to the levels that engineering requires in order to meet those smaller geometries and hit their schedules on time and deal with emergency change orders and you name it, right? It's become very difficult to scale out. So that's why we are here this week. And I'm going to spend a little bit of time kind of talking about 3 areas when it comes to engineering IT. I'm going to talk about the past. The origin of the species, if you will, including things like Unix and NFS and FlexLM. We're going to talk about the present and the things that we have to deal with today, and then we're going to move our way into the future to examine new architectural paradigms that other industries are taking advantage of, but EDA hasn't quite caught up to yet, and what the advantages of those are and whether we should be looking at them or not. So starting in the past, right? So what is past is prologue. I'm going to talk a little bit about the origins of the modern EDA infrastructure environment. Now, some of you may be able to remember a time before where I started. I'm going to probably pick up the story in the 1990s. There's certainly more history that goes before then, but if you take a look at the origins of the modern EDA infrastructure, you can really trace things back into the 90s. So it all starts with a workstation, right? I see at least one person nodding, the Spark 20, the venerable Spark 20. Back in the 90s, those were the bee's knees, right? You couldn't get a better workstation than that. And there was 1 or 2 engineers who got one and they thought it was great. And at that time, they probably didn't have corporate IT managing that thing either. You probably had some folks who were either just engineers themselves or, they may have hired some specialized IT people to support only just the engineering environment because the corporate IT people didn't want to have anything to do with that quite yet. They weren't ready. Well, that one workstation turned into several workstations, and once it turns into several workstations, you definitely had someone who was responsible for managing all those things. And of course, as word got out about those several workstations, that several workstations turned into a department. And now you're really starting to have to deal with, some level of scale. And, you've got engineers that are sitting down at their workstations and they're doing their work, they're running simulations, and all of a sudden, hey, they need to run more work than their workstation can handle and still be able to do the interactive jobs that they've got. So suddenly, you need some servers, right? And in the 90s, if you were going to get a server, you were going to get some kind of a big Sun server, the E450s, the E3500s. Maybe you were an HP shop getting PA RISC. Maybe some of you had some AIX servers, but I think the Sun and the HP ones were predominant back then. Now in this time frame, I know that at least at a couple of companies, these servers weren't actually even in a data center yet. They were probably in a data closet. And if you were lucky, you had a raised floor, but maybe you didn't even have a raised floor, and you just, all you had was that closet. And so, you start putting servers into your closet. Well, once you start putting servers into your closet, next thing you know, you need some storage. Now, maybe some of you remember this long cabinet over here on the left, this Auspex. That goes kind of way back, and that was really cool at the time, right? Because that was running, it was running a real operating system, Sun OS 4, and it was all configurable and wonderful. And it did wonderful things like RAID 5. And then, sometime around that time frame, Network Appliance came out. I remember back in the day when we used to call them toasters because they were appliances like a toaster was, right? And I don't know if we were the only ones who called them that, but we enjoyed calling them that. So, EMC had storage solutions at that time as well. So you got your data closet, you've got workstations, you've got storage, and eventually, you've got to move it into the data center, which you did. But now you've got this other problem. I've got all these workstations that I'm managing, and now I'm starting to get all these compute servers, but I need to be able to get jobs onto them efficiently. So now, you throw in a couple of other things like licensing, centralized license servers, and you throw in a batch scheduler. A lot of people went with platform LSF. There was Grid Engine back at the time. Some of you may remember things like Moab or PBS or I know that the academic folks still like Slurm, but a lot of us went with Platform LSF at the time, which is now, of course, owned by IBM, who's right over there. And Univa has got Grid Engine, and they're right over there as well. So now you've got all these servers in there that you're managing, you're dispatching jobs onto them, and one day the engineering team realizes, hey, I released the wrong version of something because someone grabbed the wrong file, and it's a mess, and I've got to go do another tape out now. So the next thing you do is you sprinkle in some CM, right?
This is paging mic test 1, 2. Paging mic test 1, 2. Check 1, 2. This is a paging mic. Check 1, 2.
All right, and so now you've sprinkled in some CM, and at least some of us had ClearCase.
Page test 1, 2.
Other folks use SVN, there's Perforce.
Paging mic 1, 2. Check 1, 2. Page mic test 1, 2. Check. Check 1, 2. 1, 2, 3, 4, 5, 6, 7.
This is one of those awkward silences like in the office, All right, so anyway, so now you've sprinkled in some CM and you've got this new infrastructure. If you've got
1, 2. Check. Check 1, 2.
Wow, they're checked.
2.
All right, so if you've got ClearCase, you've got things like registry servers to manage and VOB servers and View servers, and if you had Design Sync, you've had the Vault servers to manage. There was some form of a CM system that engineering needed. And ClearCase was great at the time because you could do things like multi-site. You could take your design and ship it from one location to another, and that became a big thing for people to do. Really helped with latency and let cross-site replication occur. But all of these things just kind of showed up. It's not like there was an architectural reference diagram for engineering IT that people could go, oh, I'm going to do that. So, in short, after all of this evolution, voila, it's an infrastructure, right? And, in some ways it did kind of resemble a Rube Goldberg device, right? Because you've got all these components that, you were just trying to put together, you were trying to meet business needs, you were trying to let engineering get their work done predictably, reliably. And in the meantime, many of us were scaling all of these systems out. So you've got, compute servers that are scaling out, you've got an increasing number of NFS servers, you've got an increase in the number of CM servers out there, and, you made it work. And it was pretty good when it worked. Now, this evolution, like I said earlier, started in the 1990s, and there have been changes. There's been lots of advances in technology since the 90s, except there's one kind of caveat to all of this, and that is that today's infrastructure looks a lot like yesterday's infrastructure. If you were to pluck a system administrator out of 1998 and bring them forward in time to 2018, they'd feel pretty comfortable pretty fast. And part of that is because there's a high likelihood that the default network version of Perl is the exact same as it was in 1998, right? Some of you know what I'm talking about at least, right? But the fundamental, so on the one hand, it is a testament to the resiliency of the architectural components that we've gotten over the years, that they have worked so well for so long, right? NFS v3 is, the original version of NFS came out 30 years ago. ClearCase has been around for 30 years. It actually started off as a file system on the Apollos before the Pure guys kind of went off and created Pure Software, which I think was Reed Hastings' first company, actually, oddly enough. And that's where ClearCase was born. Some of us at least, are still using ClearCase in your environment today. And batch schedulers, right? A lot of us are still using the same batch schedulers that we've been using for 20 years. And that's fine and that's great, except there are certain negative aspects when you've got that much legacy baked into your environment. And I'm going to talk about what those are. So now we're moving from the past and into the present. And what I'm going to talk about now is what I call choke points, interest payments on technical debt. So when you've got 30 years of legacy technology that forms the backbone of your engineering infrastructure, you're going to have to pay interest payments on that technical debt. Now, I assume that most of us are familiar with the concept of technical debt. Technical debt being that time when you say, okay, well, I know that I need to upgrade this thing. I know I need to change this component out. I know that I need to do something different than what I've done in the past. But I can't right now. And maybe I can't because I don't have the budget for it. Maybe I don't have the resources for it. Maybe it's, it's going to take too long for us to be able to do it, and I can't afford to get the downtime from my engineering group in order to make the necessary changes in the environment to modernize. Whatever it is, whether it's a conscious decision or if it's a byproduct of circumstances, we're all living with technical debt today. So I'm going to talk for a couple of minutes about physical manifestations of these choke points, and I call them the harbingers of doom. Now, these harbingers of doom, they'll show up on people's screens, and and at least some of these I know some of you will have seen, and you know that when you see them, it's going to be a bad day for somebody, right? So the first one is batch system daemon not responding, still trying. Or some variant of that if you're using a different scheduling system, right? That's particular to one specific one, but I think we've all seen some message along these lines. And when you dig into what the problem is, almost always it has to do with something getting overwhelmed in the system. There's an engineer or a group of engineers who are constantly hitting the button saying, are my jobs running? Are my jobs running? It's like kids in the back seat. Are we there yet? Are we there yet? Or maybe someone's got a script that is running out of control and is submitting hundreds or thousands of jobs per minute, per second, per whatever time unit, right? Whatever it is, it's overwhelming your batch system. And it boils down to, when you really dig into it, most of the time, the problem is that you've got one thread that's part of one process, that's on one CPU core, that's on one socket, that's on one server, that's not responding. And because of that, you got a bunch of engineers sitting around idle and a lot of equipment that's sitting around idle that can't be used properly until you figure out what's causing it and put a stop to it, whether it's calling that engineer and saying, please stop doing this, or killing jobs, or whatever it is. But it takes your entire infrastructure down until you figure it out. Can't connect to license server, connection refused. One of my personal favorites as the license administrator at Qualcomm. Whenever engineers see this, they know it's time to get a cup of coffee. Whenever IT administrators see this, depending upon what time of day it is, they may call their family and tell them, don't worry about me, I'll be home at some point later. There's a variety of reasons that will cause the license server daemon to stop responding, one of which is you have too many jobs chasing too few licenses. it's a very expensive operation in FlexLM to issue a denial for a license. It's got to go through this huge table scan in order to determine if a license is available, and it has to scan through all of them, and then it says, okay, I don't have one, so I'm going to deny that license. And if you do that dozens or hundreds of times per second, that daemon just can't keep up. You know, there are other things that can contribute to it as well. People doing constant LM stats, which is kind of like the batch version that we saw earlier, right? You know, hey, is there a license available? Is there a license available? That can cause slowdowns as well. But again, similar to the last example, once you really boil down what's happening and get down to its essence, you've got one thread in one process that's on one CPU core, that's on one socket on one server, that's causing your entire infrastructure or a big part of your infrastructure to sit idle while you figure out what's going on and correct the problem. MVFS error. So for those of you who have ClearCase in your environment, if you've seen this, you know this is going to be a bad day. Engineers don't just go for a cup of coffee on this one. They go to lunch, and they plan to be gone for a while, and administrators are definitely calling their family to let them know they're not going to be home for dinner. There's a variety of reasons that will cause ClearCase or Perforce or Design Sync or whatever centralized CM system you've got. I'm picking on ClearCase here today because I know that one the best. Don't tell anyone. But that one, again, there's lots of things that can cause this. One of which is, maybe an NFS server stopped responding that's tied into a view server. Maybe your registry server got overwhelmed because people are, doing LS VOBs, or there's a lot of clients that are coming up all at once and it's causing the registry server to slow down. It could be a VOB server that's being overloaded, right? There's lots of different reasons why this could happen. But again, it boils down to a single thread in a single process on a single core, in a single socket, on a single server that is not responding, and it's causing a wide swath of your infrastructure to sit idle and causing engineers to be idle. And that's very expensive. Maybe you're seeing a theme develop. All right, and this is the last harbinger of doom, and I know that everyone will smile in their own way. NFS server Zeus not responding, still trying. I don't know what it is with system administrators and mythology, but boy, do we love mythology when it comes to naming big servers. It's always Zeus or Cerberus or Thor or something along those lines, right? We have really big thoughts about what this infrastructure is going to be. Now, NFS servers are a little bit different. My analogy of a process on a core, on a socket, doesn't necessarily hold true because sometimes you can have engineers that submit too many jobs that are chasing too few spindles if you're still running on hard drives, right? It usually boils down to a lot of jobs that are trying to do an awful lot of write operations in one partition or one section, and the storage just can't keep up. I mean, I've also seen instances where you've got high availability setups for your storage as well. And for whatever reason, that high availability failover just doesn't work the way that the sales guy told you that it was going to work. And both sides get hung up until someone does something. And you're sending off core files, and you're trying real hard to get things back online, but it's usually not a quick process to diagnose these widespread storage problems. And in the meantime, you've got engineers that are sitting idle. But again, most of the time, it boils down to a single server that for whatever reason is not responding, and it's taking down most, if not all, of your environment. So I'm going to move into the future here in a second, but I want to spend a moment talking about, I made this comment earlier that this technology that we're using that's 20, 30 years old has gone through a lot of incremental changes over the years. There are a lot of improvements to these types of environments that didn't exist 20 years ago. It's not like storage vendors have been sitting on their hands doing nothing. It's not like batch vendors have been sitting on their hands doing nothing. They've been working to address scalability, reliability, and serviceability concerns for a long time, and they've come a long way. So I don't want anyone to take my comments on this that they're not doing their job. But fundamentally, we are dealing with paradigms that are rooted in a very small LAN type of an environment. And we don't work in small LAN type of environments anymore. And when you take a look around at the industry around us, and if you take a look behind you, you'll see some cloud vendors out there, right? Well, lots of other industries are moving to the cloud. They're adopting newer technologies, and they're able to take advantage of the benefits of some of the reliability and the elasticity and the scalability of those cloud environments. The EDA industry so far has been pretty resistant to doing that. But when you think about these harbingers of doom that I just talked about, and you compare that to cloud architectures, I think that we owe it to ourselves and to our engineering colleagues to ask the question, why can't we take advantage of these things? So one of the things that I want to start with is a fundamental tenet of cloud design, which is design for failure and nothing will fail. That's kind of a paradoxical statement at first. You think, wait, that doesn't make sense. But if you think about it in a little bit more depth, design for failure and nothing will fail is a recognition of the fact that components fail, whether they're disk drives, whether they're network drives, RAM, compute servers, you name it. There will be a failure. And we do our best today to build high availability into all of our environments. But we're somewhat limited by the technology that is fundamental and underlies everything that we do. So I want to take a moment of your time and kind of walk through a very high-level architecture diagram of a reference web app architecture and do a little bit of compare and contrast to what we have in the semiconductor environment. Now, I don't know how well you guys can see that, particularly in the back, but if you take a look, you've got a web application that's got a couple of different tiers. You have your web server tier. That's the thing that people see and they interact with directly. Then behind it, you've got kind of your business rules and your logic, and then behind that, even further, you have a database layer. Now, the first thing you should notice is that my entry point into this architecture is not pointing directly to a specific web server itself. That's a fundamental difference between this architecture and what we do today. If you stand up an LSF server, you give it a name and you point to that name. If you stand up a license server, you give it a name and you point to that name. Well, in this case, you start off at a load balancer, and that load balancer is a logical abstraction. And behind that load balancer, you can see that there are different web servers. And if you'll also notice, it may be kind of hard to notice here, but they are in what are called different availability zones or different data centers. And there's also this notion of auto-scaling. Now, if you think about a web server in our parlance is going to look an awful lot like a compute server. I'm willing to bet that all of you out there, if you lose a single compute server in your environment, you probably don't care, because your compute server is a cookie cutter, templatized thing that doesn't have any local data on it, and if I lose it, I don't care, because my data is off on NFS, I close that out, I do whatever repairs, I bring it back online. Well, it's the same kind of concept here for web servers in a cloud environment. In this case, if an individual web server goes down, well, another one will come back up because it just brings up the template. I can lose an entire data center in this scenario, and what will happen is the load balancer will say, hey, I'm suddenly not getting health checks back from those web servers over there. I'm not going to route any more traffic to them. And if you've got rules set up, you can have it so that, okay, I need 4 web servers up at all times. I'm going to auto-scale back out on this other data center over here to make sure that I've got 4 web servers. Now, the cool thing about cloud technologies is that they have this concept of elasticity, which means that not only can you go up and bring up more machines, but you can bring them down when you don't need them anymore. So if you have rules in place to say no more than a certain number of web servers, but if I need it, I can go up to that many, you can put that in and go back down. So then you've got that's the web layer. Now the web layer is talking back into your business rules engine. Maybe something that's handling your cart or that's keeping track of inventory as people check out. Whatever it is, right? But again, the web servers are doing the same thing that the end users are doing. It's going through a load balancer. And all of that resiliency that I was talking about at the web server layer, that happens at that backend layer as well. And then further back, the database layer in this example is a managed service, and in this case it's got a master read-write database, and there's also a read-only replica that's out there. And in most cloud environments you can set it up so that, hey, if my master read-write database server goes down, I'm going to promote my read-only database server to become my read-write master, and then you can take action. All of those things that I just talked about are scriptable, and they can all happen at 2 in the morning when everyone's asleep. And no one has to get paged out, and no one has to have an emergency incident. All of this can happen in code. This is really difficult for us to do in the semiconductor environment today with the assumptions that we've got. And if you go back to those things that I was talking about earlier in terms of storage, in terms of batch, in terms of using things like FlexLM, the FlexLM protocol, they began development on that. I saw a blog post recently from Matt Cristiano, who is now the CEO of Reprise, or the RLM license manager. He was the guy who originally wrote the first version of FlexLM, and he put a blog post out that he started writing that in February of 1988. FlexLM type of technology, if you try and bring that out into cloud scale or just put that kind of automation in place for resiliency, it doesn't work great out of the box. Well, you take a look at other industries and they have that ability to do that. Now, what I'm talking about is going to require a lot of conversation, and I call the conversation that needs to happen, I say that we need to have this between the 3 legs of the stool. And the 3 legs of the stool are, the IT folks who manage the infrastructure. You've got CAD folks who are building on top of the IT infrastructure, and they're putting the glueware together, the scripting, to make sure that things happen in the right order and that tools are passing off to each other. But you also have the EDA suppliers who are writing the tools. We all need to be talking together about, is this really still the right paradigm for us going into the 21st century? But that is a really big conversation. And DAC is only 1 week. So, now we're going to move even further into the future. We're going to start having this conversation at DAC this week about how we modernize and better manage the environments that we already have. Because let's face it, I'm talking about cloud, but cloud is still, even if everyone's gung-ho and walks out today and says we're going to go cloud, that's not a trivial task to take an EDA workflow and just bring it on into the cloud. There's a lot of work that needs to happen. And frankly, EDA suppliers today, there are several announcements this week from some major EDA suppliers to say, hey, we are offering services in the cloud. And I think that's great. And I have a challenge, though, for those EDA suppliers, and that's your job isn't over just by taking the current paradigm that you've got and saying, I can run that in the cloud. Those EDA suppliers need to rewrite their code to take advantage of cloud-native services, the most obvious of which is object storage. But trying to take that paradigm and put it into a cloud architecture is kind of a painful process. So this is a great start, EDA suppliers, and we need to work together to try and figure out how we take that next step into the 21st century. And we're going to do that by continuing the conversation through what I've got on my shirt here, the Association of High Performance Computing Professionals. This is the successor organization to the CLUG organization, which has existed for the license admin community for the last 12, 13 years. But we're going to expand the scope, and we're going to have 5 discipline areas: grid computing, storage management, license management, data security, and cloud. Now, this is a professional association not only for customers, but for suppliers, so that we can collaborate together on having the hard conversations about how we move from where we are to where we need to be. So we've got lots of ways to get people connected. We have a discussion board, works an awful lot like an email list. For those of you who like email lists, we've got an open source piece of code called Discourse. which is used to send email, or if you don't want email, you can interact with the web piece of it only. It's very, very flexible, but that's going to be a primary communication mechanism. We've got thought-provoking blog posts on the HPC Pros website. We are going to move towards having monthly or quarterly per discipline calls. CLUG, the licensing discipline, has been meeting monthly for quite some time now. That will continue, and eventually will be part of just the HPC Pros organization. And then we want to work on having local networking events. We've never done that before, but it's so key because so many of us are co-located in these relatively small location numbers, and it's great to get together and talk a little bit about what challenges we're having and do a little bit of informal networking. So I want to encourage you to get involved, because I need discipline leaders. I need someone to kind of take the reins for grid computing or storage or security, license management even, to be honest with you, or cloud. Someone who will drive those monthly or quarterly meetings depending upon the need for that discipline area, someone who's passionate about it. We need help with the social committee, those local events I was talking about. I can't lead a social event in San Diego, for instance, from Austin. I could try, but it wouldn't work very well. So we need folks that are local that are interested in trying to host those things to get involved. We're going to have a conference committee. I'd love to have help with the conference committee for next year's conference, because we will be back. And do you have opinions? I'm going to guess, yeah. I know you have opinions. We need blog contributors. I would love to be able to harness the knowledge that people have out in this audience and beyond to help us as an industry get better. And a lot of us, we don't have a lot of ways to get published papers in our little neck of the woods, so this is a great way to get your name out there and really show what an expert you are. So finally, I want to remind everyone, if you're not aware, we do have a networking event tonight at the Thirsty Bear Organic Brewery, which is just a couple of blocks away from us here, from 7 to 10. Now, honestly, I've had such a great response rate to this. It's really blown me away, and I'm really excited for everyone coming tonight. We're going to have heavy hors d'oeuvres, tapas, beer, and wine. We're going to be giving out 2 drink tickets for everybody. I hope we're going to be able to give everyone 2 drink tickets, but so far the response has outstripped what I thought it was going to be. So that's a great problem to have. After your 2 drink tickets are over, it turns into a cash bar if you want to continue to have any beverages. I encourage you all to come there, and I want to thank real quick, we've got some great sponsors for this event tonight, and without these sponsors, we would not be able to have a mixer, a social event where we can all get to know each other and talk about some of our problems and solutions that we've come up with. And I want to thank AWS and Cadence. Elastifile, they don't have a booth here today, but be sure and check their table out tonight. They've got a really interesting file system. The Electronic Systems Design Alliance is also a co-sponsor. They've been such a great supporter of us. And finally, IC Manage, they've got their peer cache technology, which you're going to hear more about today from Dean and Shiv, who are going to be up on this stage talking about it. So I hope to see you all there tonight. And tomorrow, just FYI, from 5 to 6 in this little area, there will be a beer and wine kind of mixer at the end of the day. So be sure and come back tomorrow if you didn't get enough to drink tonight. You'll get yourself nice and ready for the Denali party. So in closing, let me say, this is a tremendous opportunity this week to start having conversations about how we do things differently. There's no better place or time than a conference to get you outside of your comfort zone and make you more open to new ideas and new ways of thinking. I encourage all of you to take advantage of that energy this week and start thinking about how we can start talking with our suppliers and with each other to forge a new path that's a little bit more modern than what we've had in the past. Thank you all very much for taking time out of your busy schedules, being away from your family. I hope that you have a great week this week, and thanks for being here.